fourth grade, we are bringing back our math videos today. All right, so let's take a little peeky at what we're doing today. Lesson 4, problem set. And remember, if you are not sure of the goal, well, the goal always is down here. This is basically your I can statement. I can decompose fractions into sums of smaller unit fractions using tape diagrams. So basically what that is saying is that you can have a chunk of a chocolate bar and you can cut it into smaller pieces, but you still have the same amount. All right, so let's take a peek at the directions. You always want to read the directions. The total length of each tape diagram represents 1. Decompose the shaded unit fractions as the sum of smaller unit fractions in at least 2 different ways. The first one has been done for you. So as you can see, I've been working on this first one. These are actually the first set, okay? All right, so if you think about it, you can see my brown, and then you can see how I switched to red. So here's my thought process. All of this means 1 chocolate bar. Chocolate bar, okay? And then you can see how it has been cut in half. So if you look at my blue ink, well, you can see here's 1/2, here's the other half, okay? So here's one way. Then I took my red marker and you can see how I can take my half and I can cut my half in half. And now I've turned this into fourths, okay? So here's 1/4, here's 1/4, but here's another fourth, here's another fourth. Well, if I'm still looking at this, 1/4 plus 1/4 is going to equal 2/4, but it also would still be 1/2 of the chocolate bar, okay? So let's jump over here. So we still have, if you look, this is still the same tape diagram. Here is half of your chocolate bar, okay? And then it looks like they took these pieces and they cut them again. And now they turned this into eighths. So you can see how you have eighths, okay? All right, but if you look at my brown marks, well, that's still half. It's also still 1/4. So now they've taken a half, they've cut it into fourths, but now you can also cut it into eighths. So if you take a look, these are actually eighths. 1, 2, 3, 4, 5, 6, 7, 8. All right, so 1/8 plus 1/8 plus 1/8 plus 1/8 is still 4/8 or 1/2. So if you think about what would be half of 8 pieces, it would be 4. Okay, all right, so technically this is one way, here's a second way, and then here's a third way. So I think what they're asking you to do is take the same chocolate bar and show 2 different ways. So let's go down to B. Okay, so if you look at my chocolate bar, all of this is considered 1 chocolate bar. And I have thirds here. 1, 2, 3. So if you look at my green pieces, I see thirds. But now someone has come along and taken my piece of my chocolate bar and cut it in half. So let's see, how many do I have now? 1, 2, 3, 4, 5, 6. So now this is 1/6, this is 1/6, 1/6, 1/6, 1/6, 1/6. But this is all that I have. So 1/3 is also the same as 2 1/6. Or I could also say this is still 1/3. All right, come on over here. So if you look, I still have over here in my next picture, I still have my thirds. And then if you look right here, well, now this picture is now the same as this picture. But someone has taken your chocolate pieces and cut them in half again. All right, so now how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I know that my denominator is going to be 12, because now these have been cut into 12 equal pieces. And there's one right here, one right here, one right here. Looks like I need one more. 1, 2, 3, 4. 1, 2, 3, 4. Well, 1/12 4 times is going to give me 4/12. And believe it or not, that's the exact same thing as, look over here, 2, 6, and it's the same as 1/3. It's just that your chocolate pieces have been cut into smaller pieces. You don't have more, you have the same amount cut into smaller pieces. So if you take a look, it's the same. It's just that your mom has taken a tool and cut them into even smaller pieces. All right, let's do one more together. So if you look, looks like I have 1, 2, 3, 4. Well, this looks like it's 1/4. And then if I cut this in half, well, remember, these all would be cut in half. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Now, that's cut into eighths. Well, 1/8 plus 1/8 is going to equal 2/8, which is the same as 1/4, okay? And there is a way that I can make sure that I'm doing this math correctly. So how do I go from an 8 to a 4? Well, I can divide by 2. 8 divided by 2 is 4, but whatever I do to the denominator, I have to do to the numerator. 2 divided by 2 equals 1. All right, so let's look over here. Same exact chocolate bar. So this is 1/4. I am going to, instead of cutting it into one piece, let's cut these into 3 pieces. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so this is 1/12, 1/12, 1/12. I could keep going with my unit fractions, but these are my missing pieces. I don't have this chocolate right here. So it's like your brother came over and took this part, and now you're only left with 1/4, or you could say you're left with 3/12 if I go to add all these up. Okay, well, 3/12 is the same as 2/8 is the same as 1/4. It's the same amount of chocolate, it's just that your pieces have been cut smaller. So how can I make sure that I am doing this correctly? How can I make sure I'm doing this correctly? Okay, so to double check, I always go back to my unit fraction. Well, what's my unit fraction? All right, so 1/4 is the same as 2/8. Well, how can I double check? Well, let's see, how do I go from a 4 to an 8? 4 times 2 is 8. Whatever I do to the denominator, I have to do to the numerator. Make sure my hand is out of the way, because, you know, lefty. So those are equivalent to 1/4 is equivalent to 2/8, okay? Then remember, I'm going to go back to my unit fraction. 1/4 is equivalent to 3/12. Let's see, how do I go from a 4 to a 12? Times 3 times 3. So yes, those are equivalent. Okay. So let's go ahead and take a peeky at the back. Looks pretty similar. All right, so because I did it in Sharpie, you can see how messy my back is. But I was just showing you in Sharpie the two different colors and the two different ways. All right, so remember, to prove this, you always got to go back to your unit fraction to think about, are these equivalent? Are these equivalent? You always have to go back to your unit fraction. All right, so if you take a peek at this chocolate bar, 1, 2, 3, 4, 5. Well, this looks like 1, 2, 3, 4, 5, fifth. Okay, so if you were to take your 1/5 and cut it in half, what do you have now? So if you were to take your 1/5 and cut it into thirds, what would you have now? So two different ways. All right. Then, if you peek on the back, now remember, my back page is going to look kind of messy because you can see all of my work from the front. But your I can statement is still decompose fractions into sums of smaller units fractions using tape diagrams. So we say tape diagrams, think of a chocolate bar. All right. The total length still represents 1. And then it says, find two different ways. So the same thing. So if you see, I'm going to switch to a purple marker, okay? So I see 1, 2, 3. So this would be 2/3. But if I cut it in half, what would I have? I still see 2/3. But if I cut these into thirds, what would I have? Okay. What do I see down here? 1, 2, 3, 4, 5. So I see 3/5. But if I cut these in half, what would I have? 1, 2, 3, 4, 5. Yep, 3/5. Well, if I cut these into thirds, what would I have? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. What would I have? All right, down here, the very last one, it says, draw and label tape diagrams to prove the following statements. So it's saying 2/5 is equivalent to 4/10, okay? So it's asking you to draw a tape diagram to prove this, okay? And then if you can see, they actually gave you an example. So again, it's kind of messy because I was using a Sharpie. But if you look right here, here's your chocolate bar. And then this much is shaded. It says 2/5. Let's see, 1, 2, 3, 4, 5. So yes, I would agree with that, 2/5. Then someone came around, cut your chocolate bar pieces into half. Now remember, you only have this much. So now it's 1, 2, 3, 4. 4/10, okay? Another way of looking at that is 2/5, 4/10. Well, mathematically speaking, can I do this? Whatever I do to the denominator, I do to the numerator. So how can I go from a 5 to a 10? Times 2. Well, whatever I do to the denominator, I do to the numerator. Times 2. Yep, that matches. All right, so down here it says 2/6 is equivalent to 4/12. Can you draw a tape diagram that shows that?